Hello student, how are you? I'm Arun sir. Welcome to my channel Tuition Expert. Today in this class, I'll teach you the heat and temperature part 1. Topics are principle of thermometry, principle of calorimetry, some specific term, that is specific heat, thermal capacity, water equivalent. Student, if you watch my video regularly and follow my class attentively, then I can assure you that you must crack the iitjee exam and NEET exam confidently with a good rank. Now let's start about the class. So first topic is, now what is principle of thermometry? Principle of thermometry. Principle of thermometry is that suppose any temperature is for any unknown thermometer is theta, and there is a lower upper fixed point of any thermometer and lower fixed point. Suppose for Celsius scale, for Celsius scale upper fixed point is 100 degree centigrade and lower fixed point is 0 degree centigrade. For Fahrenheit scale, for upper fixed point is 212 degree Fahrenheit and lower fixed point is 32 degree Fahrenheit. The principle is that any theta minus lower fixed point of any thermometer divided by interval, this minus this interval, upper fixed point minus lower fixed point equal to constant. This is constant for any thermometer. So this is the principle. This. So if we use this principle for Celsius and Fahrenheit scale, what is the relation between Celsius and Fahrenheit scale? Suppose Celsius scale temperature is C, minus lower fixed point is 0, upper fixed point is 100 minus 0 equal to F. For Fahrenheit temperature, suppose F and lower fixed point is 32 and upper fixed point 212 minus 32. So what is the relation? Relation is C by 100 equal to F minus 32 by 180 divided 25 9. So C by 5 equal to A minus 32 by 9. Now we define some important term related in heat and temperature. The first term is specific heat. Very important term, specific heat. What is specific heat? Denoted by S or C, etc. What is specific heat? Specific heat is defined as amount of heat. It is amount of heat required to rise 1 degree centigrade temperature of 1 degree centigrade of any body of mass 1 gram. This is CGS unit. Amount of heat required to rise the temperature of 1 degree centigrade of any body of mass 1 gram is the specific heat. So unit is calorie per gram per degree centigrade. In CGS system, this is the unit. Next term is thermal capacity or heat capacity. Thermal capacity or heat capacity, denoted by capital C, or sometimes thermal capacity or capital M or C. Sometimes it is denoted by C or M. Thermal capacity or heat capacity denoted by capital C. What it is? The amount of heat required to rise the temperature of whole body. In specific heat, we take the unit mass, that is 1 gram of the body. Here we take the whole body to rise the temperature of whole body by 1 degree centigrade or by 1 Kelvin is the heat capacity. So heat capacity equal to mass into temperature is 1. Suppose the mass of any body is m, and the q amount of heat supplied to the body so that its temperature rise is 1 degree centigrade. Now what is the q? Q equal to mass into speci. It's if the heat capacity of the body is c, if the heat capacity of the body is c, then m into c into 1. So this is the formula of heat supplied. Q equal to m into c, where c is the heat capacity or thermal capacity of a body is the water equivalent of a body is the amount of a body is the mass of water which would absorb or evolve which would absorb or evolve the same amount of heat as done by the body in rising or falling through the same range of temperature, through the same range of temperature. So water equivalent of a body is the mass of water. So water equivalent will be, unit of water equivalent will be gram. Mass of water which would absorb or evolve the same amount of heat as done by the body in rising or falling through the same range of temperature. So same range, the water equivalent is denoted by W. W equal to again m into c, where c is thermal capacity. Relation between water equivalent and thermal capacity is this. So W equal to, W is units is gram. Of a body is the mass of water which would absorb water equivalent, unit of W equal to mc gram. Now what is the meaning of water equivalent? Suppose any object whose mass is m and whose thermal capacity is c. Now what is the heat required? Heat required to rise the 1 degree centigrade of the body, heat required will be mass into its specific heat. We know. Now if the if some mass of water, suppose this is a mass of water, W gram mass of water is taken. Now the temperature rise, suppose same amount of heat is supplied, q amount of heat supplied, so that the temperature of this temperature of the water rises by 1 degree centigrade. So what is the q? Q equal to mass into specific heat of water is 1 into temperature is rise is 1. So q equal to ms theta. So this value and this value will be equal. So W equal to m into c. So this is the formula. Suppose take any body, this is mass of this body is m and thermal capacity or heat capacity is c. Now q amount of heat is supplied so that temperature rise is 1 degree centigrade. Now what is q? Q equal to mass into specific heat. Now if water equivalent of this body is W gram, suppose W gram is the amount of water, suppose W is amount of water in gram, and same amount of heat supplied so that temperature rise 1 degree centigrade. Now this q equal to W into 1 into specific heat of water is 1. So q equal to m into s theta. Now equate this and this, we get W equal to mc. So this is the relation between water equivalent and thermal capacity or heat capacity of the body, where m is the mass of the body, W equal to mc gram. Now calorimetry. What is principle of calorimetry? Take any two body, suppose this is body A, this is body A, and this is body B. This body is B. Suppose mass of the body A is Ma, specific heat is Sa, and temperature initial is theta A. And here mass of the body B is Mb, specific heat Sb, and temperature is theta B. Suppose first theta B greater than theta A. Theta B, suppose temperature of the body B is greater than temperature of the body A. So heat energy flow from B to A. Heat energy flow from B to A. If the two body are in contact of different temperature, then the heat will flow from higher temperature to lower temperature until they attain a same temperature. So after some time, when thermal equilibrium will be reached, then temperature of the two body will be same. Temperature of the two body will be same. Suppose this is body A and this is body B, so temperature will be same, theta theta. Now temperature of the body will be same, so theta is final temperature of two body. So when two body are in contact, then the heat flow from higher to lower temperature, and after some time they will attain the same temperature. At this point we can say that heat lost by, this is the principle, heat lost by body B equal to heat gain by body A. So heat B lost the heat and A gain the same amount of heat that is lost by B. So this is the principle of calorimetry, heat gained by body A. Now what is the equation? Equation is heat lost is, we know, mass into specific heat, mass into specific heat Sb into temperature difference theta B, and theta is theta B minus theta equal to mass of the A into specific heat A into here temperature will decrease as heat flow from this to this. Temperature of the body B will decrease and temperature of the body A will increase. So theta B minus theta and temperature will increase. So final temperature is more than initial temperature of body A, theta minus theta A. So this is the equation for more than two body. We can suppose an example is that, suppose in a container some liquid is present. Now mass of this liquid is M L, specific heat SL, and temperature is theta L. Now here two liquid is poured. Two liquid is put in this container. This container initially present some liquid and two different liquid of different temperature. Suppose this temperature is mass, suppose 1, specific heat 1, and temperature is theta 1, and here another liquid mass 2, specific heat 2, and temperature is theta 2. These two liquid are mixed with this liquid. Now what is the final temperature of the mixture? What is the if initially theta L greater than theta 1 greater than theta 2. So theta L greater than theta 1 greater than theta 2. This is the in this order. The temperature of this liquid is more than this and this. What is the final temperature? Here, as this temperature is more, then this will the temperature of this liquid decreases and temperature of the two liquid increases. So final temperature will be this liquid lost the heat and this liquid gain the heat. So heat lost by liquid equal to heat lost by liquid 1 and liquid 2. Heat lost by this liquid equal to heat lost by liquid 1 plus heat now here heat lost by liquid this liquid equal to heat gain by liquid 1 plus heat gain by liquid 2. So this is the expression. Now what is the heat loss by liquid? This is equal to mass into specific heat into temperature theta L minus theta mix. This is to be calculated equal to mass into specific heat into temperature rise. So theta mix minus theta 1 plus m2 into s2 theta mix minus theta 2. So this is the equation to find the temperature of the mixture liquid. Now to find the temperature of a furnace whose temperature is 1000 degree centigrade or 500 degree centigrade, that is temperature of the furnace is not measured by any thermometer because temperature is very high. Temperature of furnace is very high. So to find the temperature of a furnace by principle of calorimetry, suppose this is a furnace. This is a furnace and we take a calorimetry. We take a calorimeter. Calorimeter is simple a container of copper, and here some liquid is present, and thermal capacity of this container is suppose capital C, and here mass of the liquid is m1, and specific heat is S1, and temperature is initial theta 1. Here a calorimeter is present and some liquid contains in this calorimeter, and here is a furnace whose temperature is very high. Now we have to find the temperature of the furnace. So what will we do to find the temperature of the furnace? We put a iron ball, suppose iron ball or a ball whose melting point is very high than the temperature of the furnace, and we put a suppose iron ball, we put a iron ball or some ball, metal ball, any metal ball, we put any metal ball whose melting point is high than the temperature of the furnace. Now metal ball initial temperature of metal ball is suppose theta B. Now temperature of the furnace is suppose theta S, furnace theta F. Theta F is temperature of furnace. Theta B equal to temperature of ball initial temperature of ball, and here temperature of the liquid as well as calorimeter is theta 1. Theta 1 is initial temperature of liquid as well as calorimeter. C is what? C is thermal capacity. Thermal capacity or heat capacity of container or calorimeter. Container. Now first metal ball is put in the furnace when it attains the same when it attains the furnace temperature, when it is heated and attain the temperature of the furnace, then we quickly shift the metal ball into this liquid, into this. Now melting point, now boiling point of the liquid is high. Boiling point of the liquid is high, so that no liquid evaporates. So the metal ball is quickly it will be quickly shifted such that no heat is lost. The metal ball is quickly shifted and put into the liquid, into the liquid of the container. So now this ball will lost the heat, and the calorimeter and the liquid accept the heat. So what is the principle? Now at this point we can say that heat lost by metal ball equal to heat gain by liquid plus heat gain by calorimeter. Both will accept the heat. So now heat loss by metal ball equal to what? Heat loss by metal ball equal to mass. Metal ball mass is mb. Suppose mass of the metal ball is mb. Mass into specific heat is given sb into temperature. Now initial temperature. Now the final temperature of the liquid is theta 2. Theta 2 is final temperature of liquid. So mass into specific heat into temperature decrease of the metal ball will be theta f minus theta 2 equal to heat lost by the heat lost by this is heat lost. Heat gained by the liquid will be mass into specific heat into temperature rise. Temperature rise is theta 2 minus theta 1 plus heat capacity of the plus heat gained by the calorimetry. Heat gained by the calorimetry is heat capacity. It is mass into specific heat. Heat capacity means mass into specific heat into temperature rise. Temperature rise is theta 2 minus theta 1. Theta 1 is the initial temperature as well as liquid and calorimetry. And theta 2 is final temperature of the calorimeter. Theta 2 is the final temperature of the calorimeter. So we can write this plus this. So from this equation we get the theta f. All these are known. By thermometer we can take the initial temperature. We can take the initial temperature. We can take the initial temperature and final temperature by thermometer. We record this theta 1 and theta 2, and theta f is unknown. So this is unknown. So from this equation we get theta f of heat required to change the state of any body of any body without changing the temperature is called latent heat. Without changing the temperature is called the latent heat. Now latent, what is meaning of latent? Latent means hidden, that is temperature does not change. Hidden means no change of temperature, it is hidden or dormant. This heat is absorbed by the body, and this heat helps to transform the molecule from to change the state to, it is not exposed, that is this heat cannot increase the temperature of the body, so that's why it is called latent heat. Latent means hidden. Now there are two types of latent heat: latent heat of fusion. Latent heat of fusion, that is, we know latent heat of ice equal to, which is denoted by latent heat of fusion LF equal to 80 calorie per gram. That means to melt the ice of 1 gram at 0 degree centigrade, to convert the ice to 1 degree centigrade water, 80 calorie heat is required. This is latent heat of ice, 80 calorie per gram. And latent heat of vaporization, LV equal to 540 calorie per gram. Latent heat of fusion, latent heat of vaporization for ice of water. Latent heat of fusion takes place from ice to water, and vaporization takes place from when it is converted to water to steam. So and phase change, phase means phase, solid, liquid, gas, we know there are three phase. Now when it is converted to solid to liquid, then we call that phase changes, and when it is converted to liquid to steam, then we call also the phase changes. Phase means the state of the body, that is solid, liquid and gas. There are three phases, generally there are three phases of the body. So phase change means when the body transform its solid state to liquid state and liquid state to gas state. These are called phase change. Next topic is heating curve. Suppose when we take a solid substance, when we heat a solid substance, suppose take ice of minus 10 degree centigrade, or a iron piece. When we apply the heat, then the temperature of the ice rises to 0 degree centigrade. Suppose mass is same, suppose here 100 gram mass. Now when heat supplied to the ice, then temperature rises to 0 degree centigrade. Now this is ice. Now again when heat is supplied at here, suppose this is Q1, this is Q2. When heat is supplied at here, then 0 degrees, then ice melts and it is converted to water. it is converted to water. Mass is 100 gram, mass remains same. Suppose this is 0 degree centigrade water. Now that amount of heat, if latent heat of fusion is LF, LF into 100 will be Q2. Latent heat of fusion into mass equal to Q2. Now if here some amount of heat is supplied, then this water, the temperature of this water rises and it is rise to 100 degree centigrade. Now if here heat is supplied, then 100 gram water converted to 100 gram steam, 100 gram steam, and temperature remains same. So Q4 equal to latent heat of vaporization into 100. Now if here heat is supplied, then it is converted to the ice of higher temperature. Suppose temperature is 200 degree centigrade, etc. So this is steam. This is 100 degree centigrade, 100 gram steam. Now this is water, this is steam. So this is latent heat, Q4, latent heat of vaporization into 100 equal to Q4. Amount of heat supplied at here equal to latent heat into mass. And here if heat is supplied, then it is converted to the steam of high temperature. So if we draw the heating curve of this process, of this substance, temperature of the gas rises at this portion. Temperature of the gas rises at this portion. So T1 is melting point, T2 is boiling point. So this is the heating curve. Now that is when ice of minus 10 degree centigrade is at present here. Now if we supply the heat, then the temperature of the ice rises, and when the temperature reach at the melting point, then the ice start to boil, start to melts, and this process is called melting. And when all the ice melts, then the temperature of the liquid, that is when all the ice converted to water, then temperature of the water rises, and when the temperature of the water reaches at the boiling point, then boiling starts. This process is boiling, and when the whole liquid boils and converted to gas, then the temperature of the gas increases. So these are the process. You are given minus 10 degree centigrade of 100 gram ice. You are given ice, suppose you are given 100 gram ice of temperature minus 10 degree centigrade. What is the amount of heat supplied to convert it to 100 degree centigrade of steam? Given latent heat of fusion equal to 80 calorie and latent heat of vaporization equal to 540 calorie. This is the question. So what is the amount of heat required? Amount of heat required to convert 100 gram ice of temperature minus 10 degree centigrade to steam of 200 degree centigrade. Specific heat of ice and specific heat of water, both suppose 1. It is given specific heat of ice and specific heat of water is 1. So what is the amount of heat required? The solution will be, now total heat required equal to, these are the step: Q1 plus Q2 plus Q3 plus Q4, Q3 plus Q4 plus Q5. These are the step. Now what is the Q1? Q1 equal to the temperature rises, the state is same. When state is same and temperature rises, then we use heat supplied equal to mass into specific heat into temperature rise, we apply this theory. So when temperature rises and state remains same, when temperature rises, so when temperature rises and state remains same, we use heat supplied equal to mass specific heat into theta. Theta is temperature rise. We use this theory. And when state change, then we use heat supplied equal to mass into latent heat. So now Q1 equal to ms theta, mass into specific heat 1 into temperature rise 0 minus of minus 10, this is the temperature rise. Now Q2, what is the Q2? Q2 equal to mass into latent heat, mass 100 into latent heat 80, it is giving latent heat 80, latent heat of fusion 80, is 80 plus Q3, what is Q3? Q3 equal to ms theta, mass specific heat of water 1 into temperature rise 100 plus Q4, what is Q4? Q4 equal to mass into latent heat of evaporation, which is 540 plus next latent heat of specific heat of steam, same, mass into specific heat into temperature rise 200 minus 100. So this amount of heat is required to convert the ice of minus 10 degree centigrade to temperature 200 degree centigrade. Student, this is the end of the class today. To get the more problem in heat chapter, watch my another video. Okay, thank you.